Just in case you're curious where the product rule comes from algebraically, I'll go ahead and talk about this proof. I went ahead and wrote it out because it's a lot of writing, so I'll talk through the steps. So we're trying to find the derivative of the product of f times g. And so if we use the limit definition of the derivative, we need our function evaluated at x plus h. Our function is f times g, so that's why we have f of x plus h times g of x plus h. And then we have to subtract our function evaluated at x, which is just f times g, and we divide that all by h. So now, if you're trying to compute that limit, we have arbitrary functions. This looks really messy. So what we do is we do a mathematical trick here. So what I have written in red here, I'm adding and subtracting the same expression. So that piece just simplifies to 0. So essentially, I've added a funky looking 0 into my expression here. And we have picked what we've added in here so that things will behave nicely. You probably wouldn't think to do this on your own, and most people wouldn't, but this is a trick that mathematicians use relatively frequently. So now what we're going to do is we're going to group certain terms together. So this term here and this term here both have an f of x plus h in them. So we can factor an f of x plus h out of both of those terms, and we're left with the g of x plus h and the g of x all divided by h. So that's kind of what I have here. And then these two terms both have a g of x in them, so I can factor that g of x out, and I'm left with an f of x plus h, which comes here, minus an f of x, which I have over here. Okay, now I can use the limit laws, and so remember I told you a while back that the limit laws are underlying everything that we're doing this semester, and this is one place in which they're doing that. So the limit laws tell us if I have a product of two functions, I can take the product of the limits. That's not true of derivatives, but it's true of limits. So I can look at the limit of the f of x plus h, this limit, and this limit. And so now let's look at what each of these do. So as h approaches 0, f of x plus h just approaches f of x. This piece here is the definition of the derivative. That's just the derivative of g of x. G of x has no h's in it, so as h approaches 0, g of x is just g of x. And then this is the definition of the derivative of f, so that's f prime of x. This is written in the opposite order from how I wrote it in the notes, but if you notice, we have the derivative of the first function, the second function left alone, plus the derivative of the second function with the first function left alone. So this is just the same thing as how I wrote it before, just rewritten.